So we're going to work on section 10.5, which is trigonometry and area. And the objective of today is to find the areas of regular polygons and triangles using trigonometry. In this case, remember that in this lesson, we're going to use isosceles triangles. We're going to use trigonometry that we did before. Remember that an isosceles triangle is a polygon with at least two sides that are equal, that means congruent. In this case, resulting in the opposite angles also congruent. For example, I'm going to have a triangle where the legs are congruent and these two angles are also congruent. Now, the example number one, we're going to find the area. What is the area of a regular nonagon with 10 centimeters sides? So remember that nonagon in this case are 9 sides. So I have 9 sides and I need to find the area. In this section, the area, we're going to round it to the nearest whole number, okay? And we're going to use calculator. So let's start. So this is the nonagon. The one that I have here is a nonagon, and it says that it's a regular one. That means every single side is congruent, okay? So that means if this one is 10, this segment PR is also 10 centimeters. That is on why, in this case, when I have this triangle, this right triangle here, I have 5 centimeters. So PS is equals to 5 centimeters because we do 10 divided by 2 is equals to 5. So PS in this case is going to be 5. Remember from the previous lessons, this segment here that goes from C to S is called the apothem, and I have it here. So let's start. Let's do it step by step. So I have triangle, in this case, PCR is isosceles. That triangle is isosceles. That means these two legs are congruent, so these two angles are also congruent. Also, we're going to find the measure of the central angle. So it's this angle C, this whole angle. And remember that we do it by calculating 360 degrees divided by the number of sides, which is a nonagon, so it's divided by 9, which is equals to 40 degrees. It's 40 degrees. Now what I'm going to do is find the perimeter. So I know perimeter is equals to the number of sides. In this case is 9 sides times 10 centimeters, which is the length of one of the sides. So I have that in this case the perimeter is 90 centimeters. Okay, so I have that one. I have perimeter. At some point I need to find the apothem. Okay, so the apothem, I'm going to name it CS. So I'm going to find the apothem CS. So to find the apothem in this case, look at PCS. What is this angle here? Is 20 degrees. Because I know 360 divided by 9 is 40. So in this case, this segment CS splits this angle into two congruent angles. So in this case, I'm going to have 40 divided by 2 equals to 20 degrees. So this angle here is 20 degrees, is given in your figure. I'm going to move this paper here. So I have that this angle is 20 because 40 divided by 2 is, in this case, 20 degrees. So now what I'm going to do is, remember I mentioned that PR is 10, so that means PS is 5, because we do 10 divided by 2 equals to 5. Now, to find the apothem, A, I'm going to use trigonometry. So I have 20 degrees, I have an opposite side, and I have an adjacent side. So which trigonometric relation is that one? Is the tangent. So I'm going to have that tangent of 20 degrees is equals to the opposite side over adjacent. So it's 5 over A. And if I solve for A, Okay, remember that I move A is multiply. I'm going to have A tangent of 20 equals to 5. Now I'm going to divide both sides by tangent of 20 divided by tangent of 20 degrees. So what I'm going to have is A equals to 5 over tangent of 20 degrees. So I have my apothem. This one is the apothem. Okay. Now what I'm going to do is calculate the area. So the area, remember, is equals to 1/2 the apothem times the perimeter. Because I'm going to use the calculator, I'm going to plug in the exact numbers that I have there. So I have 1/2 times 5 over tangent of 20 times the perimeter, which is 90 centimeters. Okay, so what I'm going to have, if you want to use the calculator, just plug in everything in the calculator. Right now, I just have 90 times 1/2 is 45, and 45 times 5 is 225 divided by tangent of 20. This is the area. And if I plug in this one in a calculator, I get something 618.1824. So I'm ready to give my answer. The area of that regular nonagon, the area of the regular nonagon is about, in this case I have 618.18. I'm going to round it to the nearest whole number, is 618, in this case centimeters squared. That's the solution for problem number 1. Knowing that information, remember that got it number 1, you're going to solve got it number 1. So if you want to give it a try by yourself, you can just pause this video and give it a try. So you can pause it right now. Now, got it number 1, it says, what is the area for a regular pentagon? So I have 5 sides. 5 sides with 4 inches in every side. Okay, you're going to label this triangle. It's up to you what you want to do. I'm going to use C here because it's the center. It's the center point, so I use C. And for these ones, you can use like D, R, and E. So it's up to you. You can put A, B, F, whatever you want to do. I know that this side here is 4 inches. So what that means, I already split this triangle here into a right triangle. This is the apothem. The distance between the center and the base of this pentagon is apothem. I know DR because I know DE is 4 inches. DR is 2 inches. Now I can do 360. Let me do this one. 360 divided by 5, which is the number of sides of the pentagon. So 5, this is equals to 72 degrees. So all this angle here is 72. Now, if I want to know the angle C, I'm going to do, in this case, 72 degrees divided by 2, which is equals to 36 degrees. So this angle here is 36 degrees. Now let's find the perimeter. Remember that we are trying to find the area. So the perimeter in this case is equals to the number of sides. In this case is 5 because it's a pentagon times the length of that side, which is 4. So the perimeter is 20 inches. Okay, 20 inches. Now what I'm going to do is I have the length of the base, I have the angle, which is 36. So now I'm going to just find the apothem. So in this case, I'm going to use tangent again. So I have tangent of 36 degrees is equals to the opposite side, which is 2, divided by the apothem A. So I have 2 over A. Okay, remember what I'm going to do here is multiply A in both sides. I'm going to have A tangent of 36 degrees equals to 2. So A is equals to 2 over tangent of 36 degrees. Okay, so I have my apothem here. Now what I'm going to do is substitute in the area, the formula of the area. So area is equals to 1/2 the apothem times the perimeter. So this is equals to 1/2. Area is 2 over tangent 36 degrees times the perimeter, which is 20 inches. And what I'm going to have, this 1/2 cancel these two. So you're going to have 20 over tangent of 36 degrees. And remember, the area is inches square because this one is inches. The units of this one is inches. So if I approximate this one, area is approximately equals to 27.56763 inches square. If you plug in this one in the calculator, so that means to the nearest square inch, so that means to the nearest whole number, the area of the regular pentagon is 27.5. This is 5, so that means this is going to be 28 inches square. So that's the solution to got it number 1. Let's move to example number 2. Example number 2, let's see what they want. So I have find the area. We're going to find the area. Stop sign is a regular octagon, so that means it's 8 sides. The standard size has a 16.2 inch radius. What is the area of the stop sign to the nearest square inch? So in this case, what do you know? Okay, I know the radius. I know the radius and the number of sides. Okay, here, number of sides. Okay, it's an octagon, so it's 8 sides. And then what do I need? Okay, I need the apothem. I need the apothem. Okay, what would be the plan in this case? In this case, we're going to use trigonometry. Ratios to find the apothem and the length of a side. Okay, so let's work out. I put the steps here. You're going to, if you want to use this one, you're going to get like 4 steps. So I have an octagon in this case. Remember that the radius, it's already marked this figure. So I have A, C, D. I have this length here is X. The distance from C to D is the apothem A. I already know in this case, in step, let me do it here in step number 1. I have 360 degrees. 360 degrees divided by 8 is equals to 45 degrees. And 45 divided by 2, because remember we can have another triangle here. So this one is 45. And then 45 divided by 2 is 22.5. So what I'm going to do is find the apothem, the formula of the apothem. So I have, in this case, the apothem is going to be, this is the apothem. I do have X here, and they are giving me the hypotenuse because the radius is the distance from the center to the side, and this case is 16.2. So this one is my hypotenuse. So in this case, I'm going to have cosine of 22.5 because cosine is equals to adjacent over hypotenuse, which is A over 16.2. Cosine of 22.5 is equals to A over 16.2. Let's solve for A. So A is equals to 16.2 times cosine of 22.5 degrees. Okay, that's the apothem. I'm going to leave it there. There is nothing else I can just multiply these two, but I'm going to leave it for the end when I apply the formula. I'll do this one so I don't carry a lot of decimals at the end. So step number 2, in this case, x represents AD. Okay, so I need the value of x. So instead of using cosine, I'm going to use sine, because sine of 22.5 degrees is equals to the opposite over hypotenuse. So it's x over 16.2. So that means x is equals to 16.2 times the sine of 22.5 degrees. Okay, I'm not going to multiply those two. I'm going to leave them at the end. Step number 3, we're going to find the perimeter. I'm going to label here, find the perimeter. Okay, find the perimeter. Remember that the perimeter is equals to the number of sides, which is 8, is an octagon, times the length of a side. Now the problem here is this side is x and it's only AD. So what that means, if x is 16.2 sine of 22.5, the whole segment is 2 times this value. So in this case, I'm going to have 8 times 2 times x, because I need to represent this part here. So it's 2 times x. So it's equals to 8 times 2 times 16.2 sine of 22.5 degrees. Okay, 8 times 2 times 16.2, if you plug it in the calculator, you're going to get 200, this is equals to 259.2 sine of 22.5 degrees. That is my perimeter. Now in step number 4, I'm going to find the area. Find the area. In this case, area is equals to 1/2 the apothem times the perimeter. And this is equals to 1/2. Now, where's the apothem? 16.2. So cosine, in this case, is cosine of 22.5 degrees times the perimeter. What is the perimeter? 259.2 sine of 22.5 degrees. And in this case, what we're going to do is multiply everything, plug it in the calculator, so the area is approximately equals to 1/2 times 16.2 times cosine of 22 times 259.2 times sine of 22.5, and all this one, if you plug it in the calculator, is 742.2924146. Those are decimals, and the units in this case, I have inches squared. So my solution is the area of the stop sign is about, this is 742.2, it will not round up, it will stay the same, 742 inches squared. That's my solution for problem number 2. Let's give it a try to problem number 3. In this case, remember, it's a got it. So again, you can just like pause the video, because the got it is usually similar to the previous example. So in this case, for got it number 2, a tabletop has the shape of a regular decagon. That means 10 sides. Decagon is 10 sides with a radius of 9.5 inches. What is the area of the tabletop to the nearest square inch? So what we know, I know the radius and the number of sides. What I need the apothem, okay, and the length of a side, length of sides. Okay, what is the plan? We're going to use trigonometric ratios to find the apothem and the length of the side. Remember, I'm going to start first with 360 divided by 10, which is 36 degrees. So that means if I expand this triangle here, all this angle is 36 degrees. Now, 36 divided by 2 is equals to 18. So this angle here, only half, is 18 degrees. Okay. Now what I'm going to do, remember, I need to find the value of the apothem and the value of x. So I'm going to have that cosine of 18 is equals to apothem over the hypotenuse, because the hypotenuse is the radius, because it goes from the center to one of the vertex of the polygon. So in this case, I'm going to have cosine of 18 degrees is equals to adjacent, that's the apothem, over the hypotenuse, which is 9.5. That means that A is equals to 9.5 cosine of 18 degrees. Now, I'm going to find this side length. So I'm going to use sine. Sine of 18 is equals to the opposite over hypotenuse. So it's x over 9.5. That means that x is equals to 9.5 sine of 18. You can put parentheses here around this cosine and sine. So I have my apothem. I have that half of the side of the regular polygon. So now what I can do is find the perimeter. So remember, the perimeter is equals to the number of sides, 10, times the length of one side. But so far we calculated half of that length. So it's equals to 10 times 2x, which is equals to 10 times 2 times 9.5 sine of 18 degrees. So what is the perimeter? Perimeter is equals to 190 sine of 18 degrees. Okay, so that's the perimeter. So now I can calculate the area, which is equals to 1/2 the apothem times the perimeter, which is equals to 1/2 apothem. What is the apothem? 9.5. 9.5 cosine of 18 times the perimeter, which is 190 sine of 18. And now we are going to plug in everything in the calculator. So what we are going to have as area is approximated equals to 265. If we plug in all this from the calculator, 0.238094 and 7. Now, to the nearest square inch, the area of the tabletop is 265.2. So it's just 265 inches squared. So that's the solution to got it number 2. Got it number 2 got a reasoning in this case. I have a reasoning. The question says, suppose the radius of a regular polygon is double. Okay, how does the area of the polygon change? Explain. So if you have a polygon, let me say a triangle, right? Or let's do a pentagon. This one here. You have a pentagon. Suppose the radius, so you have a center and you have a radius here and it double. So that means this one, instead of being x, it goes 2x. What that means? So if you double that value, we're going to have that the apothem, okay, the apothem and the side lengths also double. In this case, they're going to double. So the radius double, the apothem double, the side length double. So that means that the area is going to be, the area is quadruple. Okay, it's going to be quadruple because you have going to have 1/2 times the apothem times the perimeter, And let me put it this way. Let me do it this way. So one quick example is, for example, let's assume the radius here is 2. Okay, the radius is 2. And the side length is 2, right? So what I'm going to have as area, the area is equals to 1/2 times 2 times 5 times 2 is 10. So these two cancels out, so the area is equals to 10 units square. If we double everything, so that means the radius is 4, the side is 4, times 5 equals to 20. So the area is equals to 1/2 times the radius, which is 4, times 20. So this one is 2. 1/2 times 4 is 2, times 20 equals to 40. So I went from 10 units square to 40 units square. So that increased 4 times the area of that polygon. So the area gets quadruple on that problem. Okay, now let's look at this example. Now I have this triangle. I have a height, a distance AB, which is B, C, A. It brings me back all the problems from the law of sine, law of cosine kind of problems. So suppose you want to find the area of triangle ABC, but you know only measure of angle A and the length B and C. To use the formula area equals to 1/2 base times height, you need to know the height. You can find the height by using the ratio, in this case the sine ratio. So for example, if I do sine of A is equals to the opposite over hypotenuse. So sine of A is equals to H over C. Now in this case, if I want to know, solve for H because I need the height. So H is equals to, in this case, C sine of A. So now let's substitute this height into the formula of 1/2 base times height. So the area in this case is going to be 1/2 base times C sine of A. And you can just put a parenthesis here around the sine of A if you want. Now this completes the proof of the following theorem in case of which angle A is acute angle. So the area of a triangle is half the product of the length of the two sides and the sine of the included angle. So in this case, the area of triangle ABC is equals to 1/2 B times C sine of A. So I'm going to assume that A is the included angle. That's the formula we are going to use. Let's do example number 3. It's not taking that long, example number 3. Example number 3, what we are going to have is find the area. What is the area of the triangle in this case? So I have the following triangle. I have 12 centimeters, 21 centimeters. The included angle is 48. That is between these two sides. So what is the area? The area is equals to 1/2. And because I don't have ABC, I'm going to just put as formula the side length times the side length, is two side lengths, times the sine of included angle. So what is that one equals to? Is 1/2 times, I'm going to say 12 times 21 times sine of 48. So if I plug in everything in the calculator, I'm going to get 93.636248 in this case, or centimeters square. So let's give the answer. The area of this triangle is about 94 centimeters square. Okay, because remember, for the area in this case, in this section, we mentioned round up if the decimal is 0.5 up. So 93 becomes 94 centimeters square. So let's go to got it number 3 in this case. You can just pause the video, give it a try. So let's give it a try. So I have the following triangle. I have 16 inches, 10 inches. The angle in between those two sides is 34. So what I know, okay, I know the length of two sides and the measure of the included angle. Also, I can use the formula for the area of the triangle given the side, angle, side. We are very familiar. Side, angle, side from the previous chapters. So let's write this one. What is the side? What are the side lengths? So I have 10 inches and 16 inches. Okay. What is the angle measure? It's 34 degrees. What is the product? So if I use the formula 1/2 times 10 times 16 times the sine of 34 degrees. And if I plug in that one in the calculator, you can do like 0.5 if you don't know how to use your fractions. 0.5 times 10 times 16 times sine of 34 degrees. This is approximately equals to 44.7354. So in this case, to the nearest square inch, the area of the triangle is 45 inches squared. Because remember, if it's 0.7, it's going to round up. So the nearest square inch, the area of the triangle is 45 inches squared. And that's the end of the lesson. So if you have any question, let me know.